Dear listeners, I will discuss on ionic bond. Ionic bond is found in sodium chloride crystal. Sodium atoms have low ionization energies and chlorine atoms have high electron affinities. When a sodium atom comes near a chlorine atom, the sodium atom gives up an electron to the chlorine atom. They become a positive ion and a negative ion. These two ions are held together by an electrostatic attractive force, and a bond is created between them. This is called ionic bond, and the sodium chloride crystal is an ionic crystal. When the sodium ion and the chlorine ion come very near to each other, then a significant repulsive force between their nuclei appears. At a certain distance or not between sodium ion and the chlorine ion, the repulsive force becomes equal to the ionic attractive force. This is the equilibrium state of the ions. The potential energy of a charge Q2 at a distance r from a charge Q1 is U equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R. The potential energy of sodium ion due to 6 neighbor chlorine ion is U1 equal to minus 6 E square divided by 4 pi epsilon naught R. Next nearest neighbors are 12 sodium ions. The potential energy of the same sodium ion due to 12 sodium ions is U2 equal to 12 E square divided by 4 pi epsilon naught. Here the distance is root 2r. The distance between two nearest sodium ions is equal to root over of r square plus r square, that is root 2r. The total Coulomb energy E Coulomb equal to E1 plus E2, U1 plus U2, that is minus 6 E square by 4 pi epsilon naught R plus 12 E square divided by 4 pi epsilon naught root 2r. Which is equal to minus E square by 4 pi epsilon naught r 6 minus 12 by root 2, that is minus 1.748 E square by 4 pi epsilon naught r. That is minus alpha E square divided by 4 pi epsilon naught r, where alpha equal to 1.748 8. It is called Magellan constant. The repulsive potential energy U repulsive equal to B by R to the power N. Therefore, the total energy U total equal to minus alpha E square divided by 4 pi epsilon naught R plus B by R to the power N. At equilibrium separation R naught, R equal to R naught, U is minimum, and du by dr equal to 0 at R equal to R naught. When R is R naught, at that point du by dr equal to 0. That is alpha E square divided by 4 pi epsilon naught R naught square minus NB divided by R naught to the power N plus 1 equal to 0, or NB by R naught to the power N plus 1 equal to alpha E square divided by 4 pi epsilon naught R naught square, from which we can find B equal to alpha E square divided by 4 pi epsilon naught R naught to the power N minus 1 divided by N. Therefore, the total potential energy at the equilibrium separation is U naught equal to minus alpha E square divided by 4 pi epsilon naught R naught plus alpha E square divided by 4 pi epsilon naught R naught to the power N minus 1 divided by N into 1 by R naught to the power N, which is equal to minus alpha E square divided by 4 pi epsilon naught R naught 1 minus 1 by N. Look at the potential energy curves. Here U1 it is a negative energy. It is U1 curve. U2, due to repulsion of the sodium ions, U2 here, this is U2 curve, and total Coulomb energy U1 plus U2 is the red curve, U1 plus U2, and the repulsive energy due to the nuclear repulsions, repulsive energy is this blue line, blue curve. This is repulsive energy curve, and repulsive energy plus Coulomb energy combined energy curve is here U total. The repulsive energy is falling to a minimum, then it rises. Here minimum point is R naught, R equal to R naught. Here the energy, minimum energy is U naught. Thank you.